One, two, three. This is going to be a short video on another way to find the area of a triangle. Sometimes we're given problems where it's not that easy to find the area of a triangle using a base and a height, as the formula that we currently know is the area of a triangle is 1/2 times base times height. Well, let's say we're given these three pieces of information. We're given one angle and then two sides, and those sides form the angle. Well, that's not a base and a height in this case. So we kind of have to figure out what to do. Well, what you could do is you could draw the height to one of those sides, and we would still have area is equal to 1/2 base times height. Now, B I'm going to use as the base, and H I'm going to use as the height. But we don't know H. This is something that we're actually not sure what the length is because we were given A and B and whatever this angle is, but we were not given H. So I need to figure out what H actually is in terms of the things that I already know. So I do know this angle. And so if I look at this as a separate triangle, now I have a right angle, and I can tell that if this is a right triangle, the sine of C is equal to H over A, because remember, sine of an angle is opposite over hypotenuse from SOHCAHTOA. So the opposite is H, and the hypotenuse is A in this little triangle. So if I solve for H, which remember I didn't know what it was, I would multiply the A over, and I get A times the sine of C. So in this formula, I can replace the H with A sine of C. So I'm just taking H and replacing it in the formula. So a new formula, if we're given two sides and an angle in between them for the area of a triangle, is 1/2. We're going to write the A and the B in letter order to make it a little easier for us to remember. 1/2 AB times the sine of C. This is also the formula for an area of a triangle. So now we're going to do some example problems. Now, in the first two example problems, I'm actually going to do them if pretending like we didn't know that formula and just showing you that the new formula is exactly the same. So this is obviously an equilateral triangle. So all three of those sides would have, or all three of those angles would be 60 degrees. I actually can find the height because this is a 30, 60, 90 triangle. So since this is 8, and it's a equilateral triangle, if I draw the altitude, I would split that into 4 and 4. And remember, if I have a 30, 60, 90 triangle, that's a 1, square root of 3, and 2. So this height would be 4 square root of 3. That's something that we learned in a previous chapter. So if I wanted to find the area of this triangle, I could do 1/2 base times height, just like we did in the previous video that Miss Sears did, and 1/2 times 8 times 4 root 3 would end up being 16 square root of 3. 16 times the square root of 3, and that's about 27.713 units squared. Now, what if I did this just using this formula? So if I took 1/2 AB sine of C, A and B are both 8 in this problem. So the area is 1/2 times 8 times 8 times the sine of 60. 8 times 8 divided by 2, that's 32. So 32 times the sine of 60, if I type that in the calculator, I get exactly 27.713 units squared. So both of these would be the same. In this problem, I would just do 1/2 times base times height, which is 12 times 5, because I had a right triangle. So the area in the problem on the right is 30 units squared. If I use this formula also for area, I'd get the same thing. 1/2 times 12 times 5 times the sine of 90. Now, this is something that's kind of important. Um, we don't know what the sine of 90 actually is in terms of like what it means. So we won't learn that until we get to algebra 2 trig. But we can still type it in the calculator and the formula will still work for us, even if we don't really know why it's working. And if we type this in the calculator, the sine of 90 is actually 1, and we would get 30 units squared. So both of these work out. Okay, real quick, let's just do a couple of problems and get the areas here. So the area of this problem, notice we have two sides with an angle in between it. So we'd have 1/2 times 4 times 10 times the sine of 75. And when I type that area into the calculator, I get 19.319 units squared. So this is a pretty easy calculation if I know the formula 1/2 times two sides times the sine of the angle between them. Finally, let's take a look at this problem. 1/2 times 15 times 12 times the sine of 110 degrees. So if I do 1/2 times 15 times 12 times the sine of 110 in the calculator, I would get the area of this is 84.572 units squared.